example, on the one hand, the management of the fishery, and on the other hand, to what extent these introduced species need to be controlled, if at all.
Even a system as old as Lake Naivasha has its own established biological relationships, which, like Calii or Amboseli, must be understood to be managed. Here the scientists analyze nutrient levels in the water. They work out how materials are recycled in lake sediments. They laboriously sort through and count the bottom-living animals critical to fish diets. And as biologist Mutai Muchiri explains, they've concluded that right now there's an excess supply of fish food in the lake, which could safely be exploited.
This can tell us that we can introduce another species which will feed on this fish food that is in the bottom mud, and that way we should increase production of fish in the Naivasha.
For wildlife to survive, the needs of people must be accommodated, and it can be done in a damaged system like Naivasha, or with the huge Amboseli migration system, or in Caliai's forest preserve. All three cases, along with the oryx reintroduction, are examples of exceptional ecological management. But a more common situation can be found for Americans much closer to home. Called Pati Oki, grassy waters by the Indians, this wilderness is better known as the Everglades. Everglades National Park is one of the world's most remarkable places. It's a unique and complex ecosystem supporting 300 species of birds alone. Many of its plants and animals are found nowhere else on Earth. But all of America's national parks are losing species, and the Everglades is the most threatened. The wading bird population, for example, is down by 90% and still dropping.
By the way, I meant to interrupt earlier, but I was distracted by my own sneezing. The Everglades is like one of the most famous examples in U.S. conservation challenges. We've spent roughly 150 years trying to figure out where to draw the edges on the Everglades. And for a variety of reasons, we can't get it right. And everybody in environmental science knows about the Everglades boundary problem. It's a classic example of how do you define an ecosystem, especially since it's the bottom of a wetland. Everything uphill makes a big difference on what happens at the Everglades. So this is a famous example that everybody knows, probably the most universally applicable part of the movie.
The park was created 40 years ago, before the importance of ecosystem studies like Amboseli or Calii was recognized. Water is the lifeblood of the ecosystem. It used to be provided by a shallow river, 70 miles wide, which once crept steadily along the land at half a mile a day. But with modern development, the flow now fluctuates widely and is heavily polluted. The basic problem is the park is too small. Even though it covers over 2,000 square miles, it's really part of a wetland system that stretches much farther northward. But as Florida has developed, the wetlands have been drained, the flow diverted into a giant plumbing system. The flood control canal, C-38, is one small part of it. The massive C-38 takes the flow from the meandering Kissimmee River seen above it and surrounding wetlands. Along the canal, much of the former wetland now looks like this. In America, just as in Thailand or Kenya, the needs of people take priority over wildlife. This is the point where a section of the river branches off from C-38. Now, for the first time since the canal was opened, the river is carrying a full waterflow. That's because the Kissimmee is the subject of a landmark ecological restoration project. The idea is simple. Just downstream in the canal, these large water restriction barriers have been installed. They're designed to choke off flow down the canal and push water instead back through the winding river. Biologists from the state of Florida have been monitoring changes as the canal water has been diverted. When the scheme started 5 years ago, it wasn't clear what was going to happen. Nobody had ever attempted to restore a wetland system like this. They've tried to match the river's original flow rates, and about 10,000 acres of former marsh are allowed to flood seasonally as well. Signs of the dramatic results can be seen along the riverbank. The original vegetation is once again thriving. The more recent wax myrtles, which came in after the canal was built, are dying off. That one change is transforming the entire ecosystem. Biologist Lou took.
Wax myrtles are typically rapid invaders of drained wetlands in this area. When wax myrtle invaded, it represented a fundamental shift in the energy base with which the invertebrate community of this river evolved, because the leaf litter that falls into the river fuels the riverine food chain. They basically are the energy base of the river food chain, and wax myrtle is not a species with which the pre-channelization community evolved. But since our demonstration project began and we started increasing water levels in this area, we found that wax myrtle began to die out and was replaced by willow. And willow is the species that would have been found here prior to channelization. So that's been one of the benefits of our demonstration project, is the replacement of wax myrtle with willow on the banks of this stretch of river.
Until recently, the river bottom was fouled by massive wax myrtle leaves that could not be broken down by the ecosystem's microorganisms. But they can process willow leaves. Combined with restored water flow, the effect, gradually becoming apparent, has been a return to the original clean sand river bottom.
The thick layer of organic material that was present prior to our demonstration project really provided very poor habitat for any type of aquatic life, and only organisms that were very tolerant of degraded habitat could live in that type of substrate. But with the reintroduction of flow and the restoration of a more natural sand bottom substrate, we found that we are now getting an invertebrate community that is more typical of this type of system. We're finding fingernail clams, for example, which you might find in a flowing water system with a sand bottom like this.
So far, a mere 12 miles of river has been defined. If the Everglades farther south are to benefit, much of southern Florida's original wetlands will have to be restored in the same way. Only wetlands can provide the slow, steady flow of water that the park needs. So saving Florida's biological treasures will become an issue of funding and of political will.
It hasn't been going well, by the way.
But around the world, biological issues are not usually high on the political agenda.
Is anybody here from Costa Rica by any chance, or have a lot of experience in Costa Rica?
A notable exception to that rule is the small Central American country of Costa Rica. For 100 years, it's managed to remain an island of democracy and stability in a sea of political chaos. But the country is concerned about something even more fundamental. It's concerned that this is not what Costa Rica should look like. This is a man-made landscape. Before it was clear, it looked like this. It's called dry tropical forest, and it's an endangered ecosystem. Less than 2% of the world's dry tropical forest is left. The dry forests have been destroyed by fires. Throughout Central America, they are deliberately set to clear land for pasture and farmland, and then regularly reset to keep down weeds and encourage good grazing. Because dry tropical forests are especially vulnerable to fire, it occurred to biologist Dan Jansen that there was a simple way to begin restoring this rare ecosystem.
fire has not been a part of the natural fauna of this place. All the fires are set by people. Therefore, we are most interested in simply stopping the fires here because they are like a big introduced animal that runs around eating up large quantities of vegetation.
This is Guanacaste National Park, a forest growing back with Jansen's aid from the tiny nucleus of original plants and animals that were left.
Well, the point is that this is what you can turn a pasture back into. And there isn't really much doubt about that because really that's just a big-scale version of the natural restoration of forest that occurs all the time. Every time a landslide gets reforested or a whole riverbed gets reforested. And that's what all the attention has been on. But that really isn't where we are now. Because technically, now that we know how a pasture or an old field will turn back into a forest, the real question is, now that you've made this real pretty national park and you've got everything going well the direction you want it, what should you do? Just refine it? Or should you try to build it into something else? And I think the answer is we have to build it into something else. The something else is that this particular park has to become part of a bigger, more complicated network of national parks that's equally well developed throughout the rest of Costa Rica.
And that's exactly what the government is doing. They've set aside fully 1/4 of the land for parks, including examples of all the country's various ecosystems. This remarkable nation has cooperated with Dan Jansen in his restoration efforts and worked closely with many other bios in the country.
There is a major political force in this country which is based on both popular opinion and on the opinion at the presidential and ministerial level. Even if you've got your whole park system going biologically very well, you have to bring that political will to bear on keeping the park system alive.
The future of Costa Rica's wild areas is probably the most secure of all in tropical America. In part, that's the result of enlightened self-interest. There's a valuable trade in the increasing...
Oh, I wish we had that one last minute. Did we not quite get to answer this? I'm very sorry about that. It was that